Not expecting a lot of people tonight based on the engagement. Maybe they're watching baseball or college football, but regardless, we're gonna bang out a stream tonight. My It has been running a little bit slow, my internet, but we're going to. It shouldn't be too big of a problem. Shouldn't be too big of a problem. How's everyone doing? I haven't streamed in a minute, so we got some folks in here. All right. So I guess let's get started. I mean this. So for New York City folks, you're probably anybody. I'm sure a lot of people are gonna be more New England because they're gonna want to know why they got all that snow. But I'm sure there'll be a couple New York City folks or Western Connecticut, Western Mass folks that come in here and they're gonna be a little curious why it didn't work out so well for them. And it just checking. Y'all can hear me? Yeah. Okay. Just check. Just want to do a quick audio check before we dive way in. But this was an historic one. I mean, you go to the snowfall where I pulled it. Yeah, here you go. I mean, this was an historic one. We got There was a 36 max snowfall. That was pretty close to me. Pretty close to me. And I myself had just over 32 inches of snow. So this was about as big as they get for New England. But New York City busted hard. They busted hard, as you can see. We had this big old band that set up from Maine down into Long Island, and this is where we saw most of our 2 to 3 foot totals. I'm not expecting a ton of people to be in here tonight as well. I'm sure this will be more of something that people will come back and watch, or maybe they're not interested at all. I can't blame them. If you're New York City, you probably want me to stop talking about this, but I had a lot of people request this one, so I'm gonna continue. We're gonna go in depth on this, so a lot of people will be able to watch it back. But we're gonna do some cool analysis on this one. I think we're gonna talk a lot about what you can look forward to on deformation banding. Um, I've started to figure out that there's a pretty clear tell where, like, when you're watching a storm develop and where you're watching radar, you can start to tell where the deformation banding is going to set up based on it's hard to tell where exactly that band sets up until it happens. And as that band starts to get going, I'm actually gonna go into it. There's a little bit of a telltale sign where you can start to find that deformation banding. That doesn't just apply to the Northeast too. It applies to other folks as well. But first, we're gonna dive into 500 millibars. We always go in 500 millibar vort. All the P-type map stuff. If you really want to forecast, you gotta dig down to 500 millibars. That's where you gotta start. And we don't get any contour lines on here, but you can see we have a strong piece. This is our southern vort right here, and this piece is going to interject into the system, and that's where we're going to get our big time phase to happen. That was the 500 millibar setup. Notice that snowstorm gets out of the way. That was a good 5 to 8 inch snowstorm for a lot of people in New England. But then we had this really strong southern vort piece of energy, and then eventually we get this North Stream dive down, right? We get this boom, big upper level low, strong upper level low, gets a little bit of energy from those Gulf waters, really dives down, and then we watch this North Stream. We watch this northern branch of energy interject into the system. I don't know why that's doing that. You can get off the screen. There you go. But this big, this big injection, right? And we have this big lobe, this polar vortex, right? Notice this cold air that's injected in before the storm. Watch, look for this energy, right? This is a bit associated, right? Originally, the storm, this one gets out of the way, and this piece is a little too late to phase, but this really injected some cold Arctic air into the system. So we have a lot of cold air, and the temperatures were in single digits the night before. They were extremely cold, very, very cold temperatures. And remember, this was a multi-day setup. So this was the upper level low originally. I don't know if you originally remember how this developed, but this storm happened on a Saturday, got out of its way, put some nice heavy snowfall down, probably 5 to 8 inches. Computer's a little loud right now. That's fine. Means I'm working it. That's what I'm supposed to be doing. But it was, and then this big upper level low, right, gets a little bit of juice, right? Notice a little bit of energy, cuts into this, helps energize our southern vort, which is originally just a clipper system, Alberta clipper system, but it gets energized from the Gulf, pulls in a little bit of that Gulf moisture. Notice we got this big cutoff low over here. It's putting a lot of energy, releasing a lot of stuff. It's not really quite consolidated. Notice it's starting to become part of the jet stream. And as that was happening, we're injecting some energy into this southern vort, and this was able to help it really energize. And then once this North Stream kicks in, that's when we really see the storm take off, and that's where we start to back the flow and really pump moisture to meet this really cold Arctic air. And now I'm drawing a lot. Let me cut down here. So what this is the key piece right here. The timing, we have our southern vort in place. We had that in place, tapping into a little bit of this Gulf energy as well. But this piece, how quickly it was going to dive in and inject, and how strong that piece was, that was the key to this system in order for it to take off to be as big as it did. Because we have this cold Arctic injection in place, this big lobe from the polar vortex in place. And you got to remember, this pattern lasted for weeks. Not this exact pattern for this kind of snowstorm, but I mean, there was a lot. This was a very active pattern. This was about as unusual of a pattern as you can get. The 6 week time frame of storm after storm every week is basically what it was, from late January all the way until late, even early March. You could argue, from I think January 23rd to early March was the time frame for all these big snowstorms. And I mean, it's a fascinating. I'm not sure if we double closed off. I'm not sure if we had two close contour lines, but we close off 500 millibar, and we get, right, this thing gets out of the way, boom, big upper level low, and then once this piece injects into our system, we'll close off 500 kind of starts, our 500 low starts to track north, and the big question was our 500 low going to set up here, just southeast of Long Island, or was our 500 low going to set up right under Cape Cod and head out? Well, I think you can figure out that answer based on the 500 millibar loop. I'll watch here. This is our 500 low. It sets up just southeast of Nantucket, and that was the big player. I mean, I'll show you. Take a look at the model runs that we had. Notice this is a graphic from Jim Sullivan, who's a NWS Cleveland now. But he had his own blog, and I screenshotted a couple of his stuff. He's a good follow, too, on Twitter, especially for wintertime stuff. He has good analysis. Forget, obviously, we know it's a big storm. At this point, I've explained that. But notice where our 500 low is. Almost double closed off. Almost, not quite. But notice we're closed off just southeast of Long Island. Just south of Long Island. And we have a 500 look like this. This is why we saw all these big time snowfall maps that were in New York City and even into eastern New York, western Massachusetts, western Connecticut. Is with this kind of setup, what we would have done is we would have backed all this moisture. So there would have been a ton. But that ultimately, that big band, it probably would have been maybe a little bit stronger, you could argue, but also we would have wrapped a big time deformation band on the northwest side of this upper level low. In New York, New York City would have gotten hit in with this kind of model run. This was the GFS. The GFS was typically more the eastern solution, but this particular model run, the GFS decided I wanted to slam into New York City. So, and it backed off. It did back off the day before, into the night before, and so there was some evidence, and there wasn't exactly clear defined. Uh, it wasn't clear and pretty definite that we were going to see an upper level low close off just southeast of Long Island. It was still on the table to close off, just south of Nantucket rather than just south of the eastern tip of Long Island. And that was our difference. That was our difference. That was why we saw, maybe 180-mile difference, 75-mile, 70-mile difference. I was almost going to say mile per hour, but a 70-mile difference in that deformation band, and that made all the difference. I mean, we take a look at where do I have it? A little bit disorganized. That's okay. Was it this one? Nope, that's still 500. I mean, but actually, we can go here. We'll go to 700 millibars in a second, where we look more for the banding. But this is even more. I mean, this is calling an upper level low here, and I was kind of going to dip out, probably head eastward. This at this point, it's probably going to slow down a little bit more and dip out. I mean, this is calling this. This is why Philly, or borderline Philly, was. Philly would have been New York City probably. It was that's why we saw all those big, like almost foot and a half totals into Philly, because the euro was so far west, really organized, allowed a lot of energy from this North Stream to dip into our system, and when we look for this injection, we look for it to round the trough base into here and help amplify our system and help close off our upper level low. I mean, what do we have? We have 3 closed contour lines here. That's ridiculous. That's ridiculous. That's an extremely strong upper level low. With a scenario like this, with the cold air we would have had in play, probably could have seen some 48 plus inch totals with this. Almost did already, just in general. But we could have come very close, to seeing maybe 3.5 feet of snow if the euro had played out like that. We would have, instead of, this would have been, New Jersey would have got hammered, because we look for just northwest, not exactly where you want to be. You don't want to be south of the upper level low. You don't want to be over the upper level low. So Long Island probably would have got a little bit dry slotted here in this scenario. So Long Island would not have played out probably as well. New Jersey, Long Island probably would have played out like New Jersey would on this setup, vice versa of what happened in reality, where Long Island really they hit it. And also something to note too. No, I'm sure. Look at the final. If I show you the final snowfall map in relation to the upper level low, this is true with a lot of systems. Is our upper level low was closed off, right around here. And notice though that with this track, obviously the upper level low and energy strengthening. It's moving. The storm isn't moving like this, so we're not going to have a straight setup in terms of snowfall totals. However, even though the storm's moving like this, you typically see the deform band set up, and then you'll get snowfall. The biggest snowfall band is set up like that, which is pretty close, to what we saw. But what happens is when you get close to the upper level low, the closer you are to it, but still, a little bit farther to the west, you're still going to get bands to flow off. And that's kind of what happened. We saw is Long Island was still, just east of New York City. I forget, I pulled up some, let's see. I pulled up some of those totals. Just east of New York City made out really well, I think. I think they still made out with 15 to 18 inches. If I pull it up, where is it? I mean, we gotta be somewhere. Is this it? Yeah, here we go. I mean, even this is not quite even true. I mean, I remember those totals were bigger here. They were bigger. Notice a little pocket in southwestern Connecticut of 12 to 15 inches. Oh, we'll switch to yellow. But notice, just our big band set up, right here, and but we still have waves flowing off that were able to make it pass because there wasn't right on the ocean. It's hard to force a lot of Arctic air to dry up all this moisture too, which is why Long Island can still make out even on some of these, what would look like a tougher setup for up here, but Long Island can still make out because they're closer to the upper level low. Right here, they're closer to the upper level low than folks are over here in central Connecticut and western Mass. And even here, notice no big snowfall totals. Yes, the storm movement is not quite straight. It's not due north. It is a bit northeast. However, we're still able to get waves of energy to come off, and the cold Arctic air is not quite able to dry up the banding. Still close enough to the upper level low where there's good enough dynamics, a little bit better dynamics. Plus, we're also not quite as ridiculous dry air working on. We're still able to get, I mean, just east of Long Island, or just east of New York City, we're still talking 15 to 25 inches. In a lot right here, and this is west of where the biggest banding is. So they were still able to get into it a little bit from the upper level low. New York City was able to work in more than a third of their snow, probably like 40% of their snowfall just from the upper level low. They picked up 3-4 inches, and I think they finished with 8 to 10. What was their final around the New York City area, around Manhattan. And so that's something to know too, and that applied to the blizzard of 22 as well. Their snowfall totals. The band set up right here in the blizzard of 22. That's where the band set up. Yet, I think central Long Island still ended up with over 2 feet. They had, like, I thought I saw 25-inch total because they were close enough to the upper level low. Partly that's a little bit different setup, but the same thing applies with that storm where you're closer to the best dynamics. There was a little bit of separation in dynamics where we had it separated a little bit, so there was a little bit of in between, but they were still close enough. I know that doesn't quite make sense without going into the blizzard of 22, but still they were close enough to a lot of good dynamics without as much Arctic air pressing down as opposed to more inland. And that's why Long Island a lot of times can still make out really well. As long as you have good source of cold air in place, they can still work their way. If they don't get into the heaviest band, that massive deformation band, they can still find their way to get a lot of big snowfall totals. And that's what we saw with this one. I mean, most of Long Island saw over 1.5 feet of snow. It was a widespread 18 to 30 inches on Long Island. Now, we look more specifically into some of that significant band, and we take a look at 700 millibars. What we look at, this is vertical velocity, and do I have 700? Yeah, this is 700, but this is the NAM, so we can kind of compare the two. This was the euro as we got closer. It looks like the euro did make an adjustment, but regardless, it's still good enough, regardless of what the euro was showing. Now, when we look at, there's a difference between 700 millibar vertical velocity and 700 millibar vorticity. 700 millibar vertical velocity is directly where you want to look for the band. And in this case, Euro nailed it on this particular run. I don't remember the exact how it changed every single run. I don't know how that let up because I wasn't as into forecasting as I am now. This was, I mean, almost a decade ago at this point. Yeah, about 8 years ago. So I wasn't quite as into forecasting as I have been over more recent years. But no, notice 700 millibar vertical velocity right here picks up right on the band, and that's kind of where it's set up. And when you look for 700 millibar vertical velocity, that's exactly where you look for. But was also picking up on some banding to get into New York City, and it looks like it struggled a little bit with that, because there wasn't quite that, but that was still possible. I think they did even work into. I think New York City still worked into a couple bands of heavy snow. I think more earlier in the night, but they still did work into some bands, and you can compare that to the NAM. Here's the NAM. That's your difference. So remember, notice this our 700 low, our 500 low, and our 700 low are stacked at this point. And this is a good time to remind that, when you stack your 500 low and your 700 low, and your 850, you have, all your different areas, all your different levels of the atmosphere. Remember, a 500, 700, oh, that's not straight. And then you have 850, and then surface, and then obviously above that it's like 250, and then all the way up to 0. So you have your different levels of the atmosphere. When you close off 850, when you close off 700, 500, and you close all these off, and they're able to get stacked, that's a sign of a storm that is really strong, and that's able to a storm that's able to produce really strong dynamics. And that is definitely a storm that can do some damage. Snowfall total wise, probably wind wise too, assuming that's probably a pretty. You can stack 850, 700, and 500, and not have a 950 or 975 low pressure or whatever. I mean, you can. It's just a little bit. Most of the time you're seeing a dynamic system if you're stacking those different levels of the atmosphere. So here, this is 700 millibar vorticity. So when we look at 700 millibar vorticity, it's a bit different than vertical velocity because we're looking for 700 vorticity. This is where it is, but typically we will look we look from the middle, we look from here to the edge, and just past the edge is where we look for that band to set up. So this is when we do streams this year, we're gonna do hopefully a lot of winter streams. I hope y'all are praying for that too. When we do those winter streams, we are going, and when we get closer, we're going 700 millibar vorticity is where we're going to look for banding, because a lot of times the 500 millibar setup, the 700 millibar setup doesn't always quite translate to what we're looking at on those P-type maps. Those P-type maps, man, they are the death of weenies, the snow weenies. And I hate using snow weenies because everybody's a weenie in the weather. I mean, like, what the heck are you talking about? We're all invested in this stuff. We're all weenies. It's just that's for some reason that's become a frowned upon term, which we recognize, but I wish it wasn't recognized as a frowned upon term. But it is, P-type maps are, getting back to the original point, they're overused for forecasting, and it's easy to translate it to the public, but a lot of people misread them, especially because that's not exactly banding. That's just the amount of preset that they've picked up in that area for over like a 3 to 6 hour span, depending on how many frames in between there are. So those P-type maps can be deceiving. Along with that, they struggle to pick up exactly where the mixing line is a lot of times, and what the soundings say don't always match. And combine that with they don't match the dynamics as well. A lot of times they don't match 500, 700, and 850 and higher up even in the atmosphere. They don't always match. So it can be very deceiving to use those precipitation depiction maps. they can be valuable if you use them to understand what's happening with 500 millibars and the other levels of the atmosphere. They can be very useful, and they can help you identify stuff and changes in what the precipitation map may not be showing you, what it may be showing you, but you're just not comprehending, if that makes any sense. So ironic I use comprehending, it doesn't make any sense, but the p-type maps are extremely overused. If you're really interested in this stuff, I recommend you trying, and you want to learn it. Like, you don't have to want to learn take a meteorology degree. You don't have to want to get all that stuff. Like, just over time, the more you look into these storms, you can get a better idea of what's going to happen. Over the years, you can really start, and even over the months, you can learn this pretty fast. You can compare the precipitation maps, the p-type maps, with what they're showing at the different dynamics, different levels of the atmosphere, and you can compare those, and you can do this yourself. It's hard, but it's not hard to grasp how it's supposed to work. We have a lot of trouble figuring out how it's going to play out, but understanding how it can play out, at least at a minimum, is something that people think they know they can do based on they just copy and paste model runs, but it takes a little bit more than that to figure out how this plays out. So now that I've provided you with a little bit of context, 700 is important, and we're going to use it a lot in the winter streams we do for banding. I promise I will be bringing up 700 millibars for banding. So this was the NAM depiction. NAM was one of the more Western runs. Again, NAM is definitely known. Again, it's had some updates, and it will be going out. The NAM will no longer be used in 2 years or 3 years, in case you didn't know. So the NAM is eventually going to be replaced, or just taken out of the equation. But it is known for over amplifying. Sometimes it's weird, and it can have a couple off runs, may miss, but more times than not, its overall known bias is over amplification. But it is best used for East Coast cyclogenesis in the mid latitudes. That is what the NAM is best for. That's what you want to use it for. Not really for tropical cyclones, you won't. But wintertime, it has a much higher impact on people's forecasts, because it is a mesoscale model, and once you get closer in the storm, it's useful for trying to pick up on banding. So here we take a look at 700. This is where we look. Remember, I just said we want to look from here and just on the edge, just outside of that 700 millibar. And that's where we look for, probably, for our strongest band to set up. Sometimes maybe a little bit farther. It's possible. This could be a little bit more. And that's, if we play out, remember those, if, some of those folks remember those Philly snow maps getting into that 12 to 18, 18 to 24. That's why, because they were forecasted by some models to be right on the edge of that band. So theoretically, there was a scenario where this made sense. But, this goes back to 500 millibars. If I bring you, let's get back to here. Notice this. I pulled some images from Mike Masco. So I looked back, and he was really big on the storm. He was one of the people doing some real analysis, because there didn't, believe it or not, WS Twitter, there did not used to be a lot of big time analysis. Not a lot of it. There's probably the percentile, the ratio of people who did real analysis was probably higher than it is now, because there's a lot of kids trying to learn that are now on there, but there was not a ton of it. So there was not a lot available as much as there is nowadays. People post 500 millibar pics. You can find it. It's not hard to find. But what went wrong, and why we weren't able to see the snow band, set up, from, western central Mass across central western Connecticut into New York City, and even potentially just miss out on Philly, was it's hard to compare the still images versus the actual 500 millibar loop, but I've seen enough of this to figure it out. Is that we probably either the North Stream was likely either under modeled a little bit in terms of its strength. So this is what I'm talking about. We have this this was a clipper system. So this was the upper level low that originally put some snowfall across the area before it happened. And it's a strong piece of vorticity, strong piece of energy. It's pulling in now Gulf moisture. It's a little bit hard to tell, but this cutoff low was injecting some pieces of energy, pulling some Gulf moisture into the system, really amplifying this, what is now our southern vort at this point. And this is our new northern stream of energy that's diving in. This is what's going to inject itself, and it's already starting to inject itself in the system and helping the height lines point farther up, and what's going to allow our trough to go negative. Remember, this is a trough that's tilted positive. At this point, it's positive because if you look, this is where it's tilted at this point, and we haven't backed the flow. And I'll explain what that means. I'm not familiar, but folks who have been on before know this is a neutral trough. Notice our trough, this would be our trough is not tilted neutral because our height lines are pointing this way. So we're still positive, like I just said, and this is negative. This is negative. When we go negative, that's when we start to, when our trough goes negative, that's when we start, it's not that, but just imagine. We'll go yellow. That's when we wrap energy around this trough and injects in. We close off the 500 millibar and we see our low pressure that starts to intensify. And then moisture gets pulled in around the system. Remember, especially when we get really deep troughs, we're able to pull moisture in down from even into the Caribbean and into the Gulf, from the Gulf Stream. We're able to pull moisture in. Energy goes around. We're pulling in moisture too around the trough, pulling in moisture from the Caribbean, especially with really deep troughs. The deeper the trough, the more moisture we can pull in. It can take longer for pieces of energy to work around the system, so that's one thing to note, pieces of vorticity. But when we get all this moisture coming and meet, notice our cold air. This is a lobe of the polar vortex a little bit right here that was trying a little bit at this point, starting to phase with the snowstorm that we saw that weekend. So this is trying to meet up with that. So it's diving down, but it's not a ton of confluence. But this is our cold air in place, and it's really cold air. We're talking at this point, peak winter. We're late January. We got a lot of diving cold air that's going along with peak of the winter. We got teens. We were single digits the night before for many of these people, and even I think negatives probably in the Adirondacks and the White Mountains in Vermont, New York. It was really cold air. So when we have that cold air in place that's able to meet, a lot of really strong dynamics, plus this moisture being pulled in. When that moisture meets that cold air, that's where we start to see frontogenesis take place. And also, wherever best dynamics are, even just better dynamics, pockets of vorticity, convection, that's where we're able to also get banding to pop up as well. But where you meet that cold air with that warm moisture, that's where we start to see frontogenesis take place. And that's the process of frontogenesis take place. When we talk about fronts, we see a big storm, a lot of snow up here. This is just hypothetical. And we got rain on the the southeast side. And we have this front. We have cold air on the backside and warm air on the front. The cold air is meeting the warm air. And that's why we create, this would be like a line of thunderstorms. And that's why we create a strong frontogenesis. And that works the same way, in a snowstorm like this with really good dynamics. We're working a strong moisture feed to pull in. And then we're also working this really cold air to meet this. And that wasn't a good point. And that is where we get, a big time That's how we see a big time death band setup. And that's what a lot of times you want to look for when we're looking at the ceiling. How much cold air do we have in place? You don't always need, this cold temperatures, because a storm can really build its own dynamics, pull in cold air, really work cold air down, and then also pull in warm air to meet that cold air. And that's where you can get a big time death band, like I just said, to set up. So it's not always necessary, but the colder to meet a trough digging this deep to pull in really warm, deep convection and moisture, that's a recipe for you to get a really big snowstorm and a really big band to set up. And that's what we had with this one. We've seen it with other ones. The last storm we did, the February 1st through 3rd storm, we saw it with the blizzard of 22. Trough not quite as deep as this one, but still a deep moisture source we're pulling from. Nemo, blizzard of 2013. I know it's frowned upon it to say winter storm names sometimes. I don't think it matters that much, to be honest. I don't care all that much. It doesn't really affect the forecast. I may have to ask what they're talking about if I don't know the storm name, but I don't really care all that much if you don't know. I can figure out pretty quickly what storm we're talking about. Storm names don't really bother me all that much, but that's just my opinion. So what went wrong? What went wrong? I gave now with the context put in place. I put it. Hopefully that should help better understand when we're looking for this North Stream to help round the trough, inject in, help form and close off our upper level low, and the low pressure is right to the southeast usually, or just to the east of your upper level low. We're looking for this to dive down. The quicker this dives down and injects into our strong vort here, the more amplified of a system we're going to get sooner, and we're going to close off our upper level low, just south of Long Island, like we saw with the NAM and some of these Euro runs. The closer, the faster we close that off in a run like this. And that's how we get our strongest banding to set up in this area. That's where it sets up. Probably a little bit of substance in between. Because you got to remember, when you get really big banding, if I pull up our radar, or I'll just, 700 millibar vorticity will be good. There's usually a little bit of substance in between. So there's really strong lift in the atmosphere. You have rising air and descending air. I'm looking for a different word, but I can't, for lack of a better word. Rising air and descending air. So where you're creating lift, that's where your best dynamics are. But when there's so much forcing going over to that, that's not where the band is. Remember we talked about, but you're creating so much lift in this area. But again, that's not exactly what happened, but I should use blue too. You're creating so much lift in this area on either side, especially the west side, where you have a ton of cold air. Remember, where you have a ton of cold air that's working here. That's really going to cut down on how far the good banding can get outside of this band. The good dynamics can get outside of this band. And so that's going to press down on a lot of your moisture, especially with that, plus a lack of good dynamics, because they're all being forced and compressed into this area with the banding. So there, and then just to the east, there'll be a little bit of subsidence as well. And then, but you're probably on the eastern side and this close to the upper level low, you're probably still getting in. You're still getting into a lot of good banding, and a lot of the good banding that's helping form this. So you're still seeing a lot of intense snowfall rates, but probably it's not quite the same level as being in the band, because you're not consistently in a band, so you're not able to quite get to the same snowfall totals. But eventually, you might get a new band to form, or the old one decays, or the old one decays starts to once the storm starts to move out a little bit, it starts to, our band goes here and then starts to pivot. So eventually you work into the band regardless, but just not as long as where it pivoted. So people typically just east that work into a lot of subsidence typically work out better. Now, too far east is another thing with it, much more endless storm, but people typically east of the band are going to work out just a little bit better than west of the band, because let me preface by saying, unless you're too close to the upper level low and you're too close to the rain snow line, then that can be not true. But typically just close enough with a setup like this where you have really strong dynamics in here, just to the east you're still probably gonna make out pretty well in a storm like this. You probably, in this setup, you're, instead of getting the 24 to 36, you're probably still getting, like an 18 to 28 inch system, and you're not busting whatsoever. That's not a bust. You can't call it a bust just because the band was forecasting your TV meteorologist or your broadcast meteorologist to set up over your backyard, and it didn't. You didn't bust. You got like 20 to 25 inches of snow. You didn't bust. You didn't get 30 to 35, but you didn't bust. You have a better shot of busting on this side of the band than you do here. And this applies for a lot of future deformation band setups, or setups where you get a big deformation band like that. And it's not true every setup. So don't think that this applies to every single setup, because again, if you're too close to the upper level low, you're probably going to dry slot, and then you maybe start working and worry about mixing. So it's not the case for every single setup, especially if we saw a band set up here, and then you Cape Cod, Atlantic, ocean water, you have to worry about a little bit different. And then, you can you can see we can correlate the precipitation type map. I'm not sure if this is the same as the NAM I showed you, but notice, right, this is not where our low pressure system ended up setting up. It ended up being, remember, our upper level low was closed off around here at this point, and then headed out this way. So our low pressure was probably a little bit more here. I mean, this was probably maybe a 50 to 75 mile per hour difference in where the low pressure was, maybe a little bit more. And it was probably, this is when it's a little bit stronger too. So it's closer to the end of the best dynamic. So it's probably even more here. I mean, maybe not that much. Maybe even here. Remember, just southeast of Long Island. That's what we've been talking about, where a lot of these models wanted to close that upper level low. And you can even see the banding kind of faintly as NAM run. This might be a different NAM run. I'm not sure. And it's not this, may not even be the same hour image as the 700 millibar vorticity I showed you. But this is still working on this run. A lot of good banding. But it's important to know that we're kind of towards the end, so it looks like we're about 976. Also, I should note as well, I mean, a couple of alsos. In a storm that's tracking a little bit more here that we're amping up, we're probably going to see a little bit stronger than a storm that pulls out here, because that means probably not, we haven't stacked 500, 700 millibar, and 850 as well as a storm that we would have stacked, that would have came in here. Probably would have stacked it a little bit better, which is why I think also combine that with being very interior, we probably would have seen, Northwest Connecticut, west, central mass, farther west than central mass we saw. Probably work out some 40 plus inch totals. But I think we could have seen a little bit more even intense banding than we saw, which already from the band that was ridiculous. Most ridiculous band that's ever been over where I live. I can tell you that. But there are still more higher capacities you can reach in the atmosphere, believe it or not, than 30 to 36 inches of snow like we saw. And so at this point, looks like we're about 978, 976. I can't tell if there's two closed bars, isobars in there. But when we look for a storm that's intensifying, we don't look for it at its weakest point when it's just formed, obviously. But also, you would think, well, if the storm maxes out at 975, let's say right here, that means the strongest should be happening when it's 975, right? No. That is not the case. Let's say if it's 1005 here and works down to 975, 972, whatever. This is where the strongest point of intensification is. So this is why Maine at this point, that Maine was able to get in that banding because, it's still, it is slowing down, but it still had a lot of juice left to give, over this part of Maine. Still a lot to give. But this is where the most action is. Obviously this was a little bit too far offshore, but this is where your biggest action is happening because this is your strongest point of intensification. Now, these folks in the Delmarva in Jersey were a little bit too far west to work into some of these good dynamics. But in a storm that's intensifying the most from here to here, you look for in between where it's spitting out its dynamics at this point, its best dynamics, right? So remember, we're back in the flow as it's intensifying and as we're pulling in moisture this way, right? We're pulling in moisture from around the trough basin, from the Caribbean. We're pulling it in to the system to meet this really cold air, cold, dry air, meaning this warm, moist air down in the Gulf of Mexico, through the Gulf Stream and into the Caribbean. From when it's intensifying, not when it's at its strongest point, at low pressure wise, the most intense the storm is going to be for you in terms of snowfall is during this point of intensification. And that's when we're wrapping in all this moisture, and that's where we're getting all this big time frontogenesis to happen. Again, this big time death band is set up, and then we're getting tons of banding in between to help form where the strongest lift is, but just in general, really good dynamics too. And then if cold air isn't pressing enough, we can work some bands to work a little bit farther back as well. And now this part, I think some of you maybe not, maybe I'm just geeking out a little bit myself, but this next part I'm going to bring up is kind of cool. I think where you can look for in the beginning of storms, and when you can start to look for the deformation band to set up. So let's do a loop at the radar. You can see, just to start off, notice this is our dying upper level low, this right here, and this is a transfer. I should have stated that earlier. This is a Miller B transfer system. So this upper level low that's dying out over here, this is where it is in the upper level low at this point. Notice it's stronger right now. But notice as this takes over, this dies out, and this takes over at this point. All right, this is upper level low. We're watching the transfer take place. All right, our southern vort, the North Stream, is injecting more. It's wrapping around the trough base. Wrapping around the trough base right now, injecting into our system, and now it's wrapping around, and now it's pumping in all this moisture, and we're back in the flow. But if you notice, you'll watch this skinny band right here. Notice, right? Worked its way into New York City, but then also watch the skinny band as well. I'm gonna try to notice how it kind of got even out to here, this deform band, which is why people were still able to make out, because they sat in that for a couple hours probably and got 5-6 inches from just that. Notice it worked out all the way down to here, but then notice it parked camp. This is where it parked camp. Watch, if you look, you'll see it. This is where it set up shop. But this is where it got out to originally. I'm starting to realize you can figure out. So obviously we had a couple of ways, because it's really dynamic. So we had an original band, skinny band, get out this, or maybe not that far, but get out as we're starting to back the moisture. We're back in the flow. Notice that skinny band that got into New York City, so they were still able to make out, and they're close enough to the upper level low. They still worked into some good dynamics and banding. So New York City wasn't a total loss. It could have been worse in New York City. I know that's hard to believe based on what you got, but it could have been worse. But this is another. If I show you another example, a couple different examples as well. If well, first I'll show you, more in depth. Right, this is 4:15 at this point, and I'll be able to show you. Actually, I put a few side images together. Notice our band. This is from the Long Island radar. This is where our band was at 2 a.m. So even almost into western Long Island, it's on the edge of this band. That's why we saw this was around where the cutoff was. This was like 8 to 16. This, and then anywhere east of here, this is where the 18 to 20, 18 to 24, 24 to 30 inch totals were. And we're probably going to want to switch to blue now. But then notice, we get to 3 a.m. The band's starting to set up shop a little bit farther east. This is how far I was able to get. And now we get to 7 a.m. And now notice our band, maybe not that much. And now notice our band is setting up here over, what, Rhode Island, eastern Connecticut, and central Mass, and into eastern Mass as well, and then into southeastern New Hampshire. So notice as our band is starting to figure out where it's finding place, typically when you look for on radar, what you want to look for is how far is that skinny band originally going to make it, and then look just to the east. That's where you want to look on radar when we're looking, for these big deformation bands to set up. This is where we want to look. Again, more images. Boom, boom. And then we look at 8:30, right? The storm's starting to pull out this 8:30 a.m. Now notice more of eastern Mass is working into it. But at this point, it kind of stalled at this point. So it's a little bit farther, but not really. So it's stalled at this point. And so from the best dynamics were probably more 3 to 5, 6 a.m. That's probably, but it's still really strong. It's still intensifying at this point. But remember, we look for from its weakest point to its strongest point is when we look for it to be the strongest, to see the best dynamics flow off the system. So it's the probably maybe not quite as strong some of those snowfall rates, but like we're talking the difference between maybe 4.5 inches and like 4.25 inches max per hour, which is obviously it's not a big, someone probably maxed out like 5.5 inches, honestly, with this band, with the good ratios, the good cold temperatures, fluffy snow able to accumulate more. Probably someone maxed out 5.5 inches per hour, and now we're talking more 4.5 inch per hour maxes. So that instead of 5.5, maybe like 4.75 max. Like this is just semantics, but every little detail matters. If you know me, I'm big on every little detail. If there is any YouTube folks in there, I promise I'm going to take questions eventually. I promise, if there are any YouTube folks in there. But I feel like I'm cooking on some of this analysis, so I'm going to keep it going. Now, so at this point, from, if I take a look at 6 a.m. or whatever, this is a 4:15. So 4:15, that's the center. This is, and this is the edge of the band right here. At 4:15, that's all over Eastern Connecticut, Central Mass, and Western Eastern Mass. And notice, remember we talked about subsidence? A little bit of subsidence. Waves of precipitation and moisture flowing off. Still flowing off, pumping. And you got another. This is almost a dual band. So you got a good band up here. I think they did well too. I think they did really well, this area. Maybe not quite they didn't get quite the 3 feet, but this was widespread, 24 to 30 inches. And this was less 18 to 24, more widespread, 24 to 30, I think, in this area. Notice, it's 4 a.m. Go back, go even further. Central Mass is in it significantly. Radar kind of cuts off. Eastern Connecticut in it 2 a.m., right? 3 a.m. they're in it. 4:15 we just showed you. And then look, 6, this will be better. All right, this is 6:30 a.m. Band is setting up shop right over here. This is where the band is. They're still in it. So this is 4.5 hours, 5 hours at this point that they've been cooking in this band, this area. Now we play it to 8:30. Guess where the band is? From around 6 to 9:30ish. This band stalled. It stalled over this area, and this was 3 to 4.5 inch per hour snowfall rates for 3-4 hours. Just stalled. Now it's the storm itself isn't quite stalled, but it's pivoting. So the band itself, where it's located, is stalling because it's moving from here to then here. No. To here, and then from here, and then here. That's how the band is stalling, and then until it pulls out. That's how the band is moving. So notice, more frequently than not, this area, and that's where we see the heaviest snowfall rates, and that's where it's set up. So when you're consistently sitting that long in such heavy snowfall rates, that's how you get 3 feet of snow like that. That's how you do it. You get that band to pivot. It's not just being in the band for a little bit. It's you being over the axis of the pivot point. That is how you get 30 to 36 inches of snowfall. And remember, we went back to like 2:30 a.m. Eastern Connecticut and Western Central, Eastern Central Mass. We're still in that band. So it's been 7 hours that they were in 3 to 5 inch per hour snowfall rates. Plus the snowfall, they probably got 4 to 8 inches before that. Maybe not that much, but 3 to 7, maybe 3 to 6, 4 to 8. And then you add on what they got after the band started to kick out. Excuse me. They were still getting into good snowfall after. I'll show you. Take a look at the radar loop. Still working into pretty good banding. Right now it's moved out, but still got banding that's still popping up. And you still worked in probably another 3 to 6 inches, after like 10 a.m. So a 6 to 12 plus, a good, 16 to 24. You add that up. It's, 22 to 36 inches. That's about 2 to 3 feet. And that kind of makes sense when you add it up. That's how they got all those big time snowfall totals. How I got into all those big time snowfall totals. I don't have the image up, but I have an image of me. It wasn't the exact measurement, but it was just me measuring an area of, I kind of tilted it, but it was just because it was a little bit uneven, but it was, me measuring down, and it was 31.5 inches. Um, and it was probably a little bit more compacted at that point. So it's probably more, snow depth was probably more 28, 29 at the very end. But because that is something, if you were curious about measuring the snowfall too in a long duration storm, how you want to do it is, I recommend, if you're not really professional, technically it's like every 6 hours. Technically it's and I did that a little bit in the beginning. Once I figured out it was every 6 hours. But then I've decided, I'm going to go more at like every 8 hours, because I think it skews it too much a little bit. I think it skews it a little bit too much. But every, a long duration storm, you want to measure it probably around every 12 hours. If you have a 24-hour system, I would do 2 measurements, and and that's how you probably, you add those up, because snowfall compacts, especially if you get really heavy wet snow. It's heavy, right? The density of the snow, so it's just going to want to work down faster naturally. And if you have really light snow, regardless, if I get 1 inch of rain equivalent to 10 inches of snowfall, that's how much the liquid is going to be. But if I have better ratios, and let's say I got 15 inches of snowfall, eventually there was only a certain amount of liquid that came out of the system, so it's going to have to work down to there eventually. So we'll compact a little bit slower. But if you ever notice, the snowfall compacts, let's say the storm stop maybe 3-4 a.m. or 3-4 p.m. If you don't measure until the next morning, or let's say it stops 6-7 p.m. and you don't measure until the next morning, it's probably going to compact a bit. You're not going to get the best, not the best, just the most accurate snowfall measurement. So it's important that if you do carry, you want to get the best measurement you can, the most accurate measurement you can. I recommend, as soon as the storm stops, that's when you get your measurement, because snowfall does compact, and right away it starts to compact when it stops snowing. That's probably something a lot of the general public doesn't know, which is fine, and it doesn't skew it that much, but it's not completely always accurate. So, just another tip as well, for those that maybe didn't know. I mean, it's just, remember, this is such a long that you can see it, the event eroding, right? It's starting to weak, right? This is weakening. In our energy, this piece of energy vorticity is taking over. And from when it intensifies from here to here, that's not quite it, but you just follow. This is where its strongest point. So now this is where the strongest is happening, because this is where it's intensifying the most. And as now it's stopped intensifying, notice the banding is going to die down slowly as too, and kind of just fade out. If you're not moving, excuse me, it's not moving real fast, which typically a storm that gets this strong isn't going to move all that fast, your banding is just going to erode and stall out over areas. So notice this part of Maine did not work out too well. Northern Maine, central Maine didn't get, they got into a little bit. They made out pretty well, but not quite the same as this part of Maine into New Hampshire, Rhode Island and eastern Connecticut, central Mass, Long Island. They didn't quite have the same best dynamics, and they probably compacted a little bit faster because they were really cold as well after their snowfall. Just a little side note, but probably not quite the same dynamics at this point. So I forget what did Maine finish out with, but yeah, definitely not quite the same. I mean, what was well, let's take a look at that total there. Oh, I have it on the slideshow. Yeah, so as you can see, not quite. Excuse me. I've been talking a lot, so my voice is like drying out on me. This is your 15 to 20 inch, it looks like, maybe. So yeah, at this point, it's a lot of, this is, a lot of 8 to 16, a lot of 8 to 16 at this point, where this, because the storm is weaker at this point, so we're not producing as good dynamics and not as good of a moisture flow, not as good of a moisture source at this point pumping into the system. Well, the source of the moisture is the same, but the dynamics aren't as good, so you're not going to get as good frontogenesis as we were down here. So back to what I was talking about with that banding too. What you want to look for is, notice, remember we were talking about it. It's just the dog. That's fine. What you want to look for, notice it sets up here, and then it starts to, looks like it wants to set up here, but then it starts to contract a little bit, and this is where we look for it to set up. And maybe not quite that far, because it's gonna contract a little bit more, but that's where we look for the band to set up, and then eventually tick out this way, because that's the pivot point, and that's how Boston eventually ended up working into the band and into, I think they finished with like almost 2 feet on the dot, even though Logan's not a great spot to measure. But and then notice this applies. Remember, I said it applies to other storms as well. Take a look at this was the blizzard of 2022, and this is the same storm. I pulled 2 different examples. So notice this was the big band happening. This was the big band happening. And notice the substance, right? We talked about there's substance in between here. But this little deformed band is going to form. Ironic. This band's, but notice where it originally sets up. It starts to set up here, but then it contracts. And we watch it set up right over here. This is where then the band sets up. Delete all that stuff. All right, starts here. This is where it starts, but then it contracts and works right here. So this is not just that wasn't just a one-time thing or example. This happens, literally twice in the same storm. If I watch this. Look at the skinny band, right? Notice now it's pushing here, and you had this band already set up initially. So you had a couple of bands set up originally. Really, remember, a lot of good dynamics. At this point, the moisture isn't compressed as much. We still haven't quite seen the band form, so it's still taking into place for you. So we left. So there's a little bit of funny in the blizzard of 22. We saw a little 18 to 24 pocket in eastern Connecticut, in northwest Rhode Island as well. And then that band that ended up setting up later, like I just showed you, that also produced another, 15 to 20, 23, 22 inches. Another pocket of that. Good 16 to 22 inch pocket from that band as well. But notice, remember we were talking about, this is where the big D4 band is going to set up. Right over here, this is where the band's going to set up. We got substance in between, but this is where the skinny band kind of made it as far as it could. And then once I saw this band kind of run its course, I was like, maybe I'll get into the edge of it. And I was on the edge of it for a few hours, but as more cold air was being pulled into the system, more dry air was working against it, and it really forced where the best dynamics of this band was going to be, and it forced that area to get into the best snowfall. So that's something that I'm going to be more. I'm going to pay attention more for future storms as well. I'm definitely going to talk about that on streams as a talking point because, I just kind of picked up on it. It's not like groundbreaking or something, but not many people, people realize it, but not many people actually, talk about it as a talking point. So when people freak out and trying to figure out where the band sets up on radar, the night before, the day of, this is something that when we do some live analysis, we'll be able to use. And oh my God, my voice is just killing on me. So when you get such a dynamic system like this, I mean, remember, look at the max, right? This is the vertical velocity of the banding, right? 20 to 20 plus is the max. Maxed out. Yep, we're maxed out. Right over here. So this is really strong dynamics. Remember, it even picked up. Remember, I showed you that dual band. Euro even picked up on that dual band. Let me show you that. Kind of on that one, but not good enough. Was it this one? No. Oh, I think it was this one. Nah, it wasn't even that one. Oh, this one. Here we go. Picked up on that dual bend, and right here, notice that little bit of subsidence in between. And remember, we're back in the flow. A lot of pumping this moisture. And remember, I talked about it. These dynamics, you're probably going to see snowfall rates almost, if not just as heavy as what you're seeing in the band. But you're kind of going in and out of this a little bit more. So it's not as persistent and consistent as much as you'd be inside of the band directly for long enough. So this is pumping into where the best dynamics are, and then band cuts off here. So it's going to, band cuts off here. So all this pumping in, and this is where our 700 volt is, probably right here. So all this moisture is going to pump into the best dynamics, and that's where we see, this is where the best lift is. Moisture meets where the best lift is, and that's where we see all this heavy snowfall get centered right into here. And then remember, it's not just getting into the band, it's being on the pivot axis. So it's being from this point and then working into this point. This is not the same location, but I'm just trying to show you an evolution without making a big mess and drawing all over, and then getting to this point. So it's being able to work the same way. And if I drew over it to represent, so this for the band, and then it's going to pivot to there, and then it's going to pivot. That's an over exaggeration, but notice everywhere I drew, these folks were in it the whole time. And that's why we saw, and the pivot point goes farther north, but I just didn't draw it as far. So that's why we saw these folks pivoted it into the band for the longest, and that's why they saw the heaviest snowfall. It's not a rocket science, really. Now I feel like I broke it down pretty good, so you get a good gist of it. Me just breaking it down. I went really into depth to make sure you could understand. I try to provide a lot of context, which maybe not everyone does, but all the little stuff is important to me, because I remember when I was trying to understand it, there were so many little things I was trying to put together, and well, I don't fully understand it. I don't think anyone fully understands it, but I know especially I don't fully understand it. I have a good idea. And so, this is a once in a generation kind of storm here. This is not something you see every day. Oh, YouTube folks. Oh, we do have some YouTube folks. Oh, okay. Yeah, YouTube. If anybody has questions too, YouTube, Twitter, regardless, feel free to ask as well. Bro, look at a couple last things here, and then go into questions, and I'll answer. There's not a ton of people, obviously, not expecting a ton of people at 1 a.m. But whatever you got, I'll try to answer. Spit. And this was the difference between the GFS and the Euro too. Notice this is where upper level low is closed off right here. This is a big difference between the Euro trying to close off the upper level low here. But notice right here, this is a little close to the upper level low. Such a dynamic and such a big system. Oh, I almost drew something. I don't want it to. But that's this right here is probably dry slotting a little bit, just so close to a system so wound up and so intense. So you don't always want to be too close to the upper level low when we're looking at dynamics. This is such strong dynamics. But I mean, it's just a beautiful almost near textbook. Near textbook. And some of those folks probably wish that this thing wound up a little bit sooner. I know New York City does, because if New York City, it's just no one talks about a bust if New York City sees like 18 inches. No one talks about a bust if they see 8 more inches. I know from moving from 10 to 8 is a lot different from moving to like 20 to 28, but I guarantee you, no one would be talking about a bust for New York City if we just a small shift. Remember that. I mean, some of these snowfall totals. If we just see, I mean, I wanted to expand out a little bit more. I mean, if we just see, this was the 12. This was the 12 to 18 right about here. I mean, 15, 20 miles. I don't think this is as historically bad. Obviously all these folks get shafted. Everyone in here gets, I should use yellow. Obviously everyone in here gets shafted. Or, I mean, if it moves a little bit farther west, it's probably everyone in here instead. Everyone in there gets shafted. But, it's a little less populated, not as big of a deal as New York City itself. So it's probably New York City was a 20-mile shift probably. It's probably a little bit more wound up too. You're probably able to force a little bit more better dynamics even farther west of the current setup. So it's probably, every 15-mile shift of the actual banding, maybe another, 3, 4, 5 miles added onto that, if that makes any sense. So New York City probably, this 12 to 18 is probably maybe a little bit more 14 to 20, which is, it's small details. But I'm big on the little details, the little things. It's important. I'm going to go over a lot of the little things. So these streams will probably be pretty, in the wintertime, they'll probably be pretty long, which I'm sure some people will enjoy because, they want to get as much information. And I know in the wintertime, these are going to get packed. So. And there's going to be a lot of questions, just based on the growth we had on this channel, not channel, but, based on, I mean, even I guess YouTube channel and just the hurricane season, we added, 30, 40 subscribers. I think it was, like 40 subscribers we added, maybe more like 30, more like 30 just from, just from hurricane season. And that was just one hurricane that wasn't even hitting the area. So, our area. Now, I don't live in Florida, but I think wintertime we're going to be able to get a lot of people in here, ask a lot of questions. And last year we went from like less than 2,000 to like 4,500 on followers on Twitter. So it's not like I don't do this for the followers, as I've told time and time again, but you do notice it. It's a notification, so you notice it when it happens, but. I'm glad I'm glad people have grown fond of some of my analysis over the past and forecasts over the past year or so, particularly in the past year. And I think we're gonna have a really good jump with the new stream setup. I think a lot of people are gonna find it a lot more enticing to take a look, and also jump on. Or a lot of these YouTube folks, they don't come in until like 2 a.m. or whatever. So that they're kind of, a lot of my YouTube folks have been like late folks, late. So they typically tend to wait a little bit longer. I'm not sure. We had any. A lot of different folks have popped in, which is good. So at some point, and they'll be able to rewatch it as well, which is, I'm sure we had a lot of different people pop in, just not consistently, which is, I'm pretty satisfied with how many were going. I must have, I guess that's a good sign that it was a successful reanalysis, but this was, dynamic. This is even more GFS high res. Interesting. This is really more. This is a really good demonstration of the north. Notice you can really see the north stream kicking in. We'll go blue again. All right, so this is our main vort, right? Our upper level, what was our upper level low. It's kind of, what was our energy, pumping moisture here. This is now starting to fade at this point. Right, we can see our upper level low, right in here. And this north stream is now diving into the system, intensifying it, wrapping around the trough base into this to help consolidate our upper level low, which is moving out this way, or this way, whatever, moving east northeast roughly. And this is at its strongest point. So this injecting into the system is another way of looking at it, this being our strongest point. This piece injecting is helping intensify. So as this is injecting, notice all this convection firing up. And this is a little bit, we talk about this too, we're going to continue. This is probably a little bit of convective feedback. And what I mean by that is a storm that we're still, damn, we're still not quite fully, pumping negative, but yeah, scratch that. We've gone negative at this point, but not as crazy as before. So when I'm talking about convective feedback issues, is this typically a storm this strong, not a double barrel. It tries to kick this out when really it should be more consolidated. So all of this, makes sense, but it's this piece, it's this last piece right here trying to form convection here. The GFS model is the biggest one at trying to do this. When the trough isn't able to go negative, when the trough is in the process of going negative, it loves to, for some reason, shunt all this convection and shear it away from the main point of consolidation of where the upper level low is. And so it likes to weaken systems a little bit in the beginning, and it can pull storms further east. And then once it starts to get closer, it starts to figure it out. That's why a lot of times we see the northwest trend take place. Now, obviously not that far, but I'm just pointing the direction. Just a fascinating storm, really. Yeah, so we're negative at this point. That's not a straight line, but just checking. I'm sure. I haven't streamed in like a week or whatever, 10 days or so. So I'm sure the YouTube folks aren't really expecting me, and I don't think I have enough followers to be able to do or subscribers in a watch time, whatever, the 1,000 mark or whatever, to be able to put community tab posts out. I wish I had that access, because then I could just send that out for the folks that are actually interested and want to, tune in. Because when you have so many, followers or subscribers, I'm not saying I have so many, but when you have enough, that just statistically, not everyone is going to be coming in at the same time, or everyone is even going to come in at all if they're even interested. People have different interests, different time, work hours. Maybe they don't even know they're still following you or subscribed to you, etc. So that's why I wish I could put community tab posts out and send those out on YouTube, because it's the equivalent of me sending out a tweet. This is when we're live streaming, so then I can let everybody know. Because if I just pop up a live stream, people will pop in, but maybe some people are actually interested and want to take time out of their day to listen to it. So it could be different people, different things, and also you never know, Friday night, what someone's doing at this point. But yeah, this was man, my voice is, oof, for some reason tonight exceeded its limit. Officially out of my water. Damn it. That's all right. But yeah, this was, as intense, but almost as intense of a band you're gonna see. And overall, there's not a lot of 3-foot snowstorms that happen. It takes a lot of stuff to happen correctly. So this is why when you get that opportunity, it hurts even more, because it's really hard to get 3-foot snowstorms. Really hard to get 3-foot snowstorms. So this is, I'm never going to take, I took this one for granted a little bit. I did sleep through some of the band, because I'm still getting into forecasting. So I wasn't fully understanding of exactly what everything was happening, but man, this was a one for the ages, and one for people to forget as well. One for people to forget, no doubt. Especially if you live, if you live west, of here, you definitely probably want to forget this storm. You definitely want to forget it. But yeah, fascinating system. And we'll do another. Any last questions? There's only like 1 or 2 people in here, but if you do have a question, feel free to ask it. But we are going to do hopefully another. I don't know. It's hard. Stuff works out, or maybe I think the Celtics are playing Friday night, so maybe we'll do a stream after. That actually, a stream would be a good thing, because I might be in a better. If I'm in a bad mood, then it could be a good thing. But if I'm in a good mood, regardless, that could be good too. So we probably good decent chance we'll do a reanalysis stream next Friday night, as long as I have nothing to conflict. We'll do around the same time, probably. Hopefully a little bit earlier. Hopefully we can do 20, 30 minutes earlier. And we'll do another reanalysis stream on the blizzard of 2022 last year. Which I'm sure New York City will be a little bit more interested in that one, even though they kind of missed out still. The expectations were much lower for New York City. So I forecasted 7-14. I think it was 7-14 with a 12-24 ceiling. So that worked out pretty well, because New York City, I think, was 9 to 12 inches, I think they saw. So that forecast worked out pretty well. But I think without further ado, again, there's no last questions. We'll call an end to the stream. Feel free to go back and rewatch it if you want to rewatch it on YouTube. BGWX is same name for my YouTube channel. If you want to go watch it there, or go watch if you're just seeing this at the end now. You want to rewatch it on Twitter, if not through the Twitter Live, Twitter broadcast, whatever the hell it's called. Feel free to watch it. But yeah, again, we'll do another stream. Hopefully, another stream next weekend, next Friday night. Hopefully, not a guarantee if I have something, but yeah, I appreciate everyone that came in, and I'll be on the Twitterverse. Over assuming there's no hurricane that wants to form, and then within the next week, we probably won't do a stream. But until then, thanks everybody, and peace out.